Hello everyone, welcome back to uLearn Education Online channel. In the previous video, we have seen how to draw the frequency spectrum of AM signal with the assumption of message signal as a random signal or an arbitrary signal. Okay, and also we cannot say that the random signal is consisting of a single frequency. As we don't know the mathematical expression of message signal for a random signal, we may assume that the random signal may contain a single frequency or more than single frequency. Okay, but with some necessary assumptions we simply draw the frequency spectrum of an AM signal. Now in today's video we are going to see how to draw the frequency spectrum of an AM signal by considering or assuming the message signal as a cosinusoidal signal. Here we assume that in first case the message signal is having a single frequency. In that case, how the frequency spectrum of AM signal will looks like. And in the second case, if we assume that the message signal is having more than one frequency, for that case how the frequency spectrum of AM signal will looks like. Okay, so I am considering the case 1, that is the message signal m of t is having a single frequency. Okay, so if the message signal, and here the message signal, that too we are assuming it as a cosinusoidal signal. Okay, so if the message signal contains a single frequency component, then we are calling that modulation is called a single tone modulation. Now what do you mean by a single tone modulation? The single tone modulation implies the message signal, that is m of t, should contain a single frequency component. That case we are calling it as a single tone modulation. Okay, if, and the other case if I consider, if the message signal m of t is having more than single frequencies, then we are calling it as a multi-tone modulation. Okay, so this multi-tone modulation is having a more number of frequencies. Now for these two modulations we have to see how to draw the frequency spectrum of AM signal. Now in today's video we are going to see how to draw the frequency spectrum of AM signal for the single tone modulation, and in the next video we are going to see how to draw the frequency spectrum of a multi-tone modulation. If I repeat in brief, the single tone modulation is nothing but if the message signal is having a single frequency component, then that modulation we are calling it as a single tone modulation, whereas the multi-tone modulation implies if the message signal is having more than single frequency, then we are calling that modulation as a multi-tone modulation. Okay, now let us consider how to draw the frequency spectrum of single tone modulation in an AM signal. So in the single tone modulation we are saying that the message signal is having a single frequency component, and here we are assuming that the message signal is a cosinusoidal signal. So if I assume the message signal as m of t, and this m of t is having a single frequency component and it is indicated with fm, and now here we are assuming it as a cosinusoidal signal. So finally I can write the message signal expression in single tone modulation as am into cos 2 pi fmt. Now next step what we have to do, we have to draw the frequency spectrum of message signal. So how to draw the frequency spectrum of message signal? By applying a Fourier transform to m of t. So simply apply the Fourier transform to m of t. So we will get the Fourier transform of m of t is indicated with m of f. Okay, so which is the Fourier transform of am cos 2 pi fmt. Now we will know what is the Fourier transform of am cos 2 pi fmt. So it is an impulse signal equation, that is am by 2 into del of f minus fm plus del of f plus fm. So this is the Fourier equation of a modulating signal or a message signal. Now next step is we have to draw the frequency spectrum of m of t. So if I draw the frequency spectrum of m of t, then what signal it looks like? It looks like an impulse signal. Why it looks like an impulse signal? Since the modulating signal frequency expression will consist of only an impulse signal term and with a shifting frequency of FM with an amplitude AM by 2. So if I draw the frequency spectrum graph, then it is F and it is M of F. So the first term is an impulse signal with a shifting frequency of FM. Okay, so this is FM and its amplitude is AM by 2. Okay, and what is the second frequency term? And the second frequency term is again an impulse signal with a shifting frequency of minus FM and which is having an amplitude AM by 2. So I can write it as a minus FM which is having an amplitude of minus AM by 2. So this is how to draw the frequency spectrum of message signal. Now let us see how to draw the frequency spectrum of carrier. So here the same expression we are assuming for the carrier signal. So repeat the same procedure. Here the carrier signal we are assuming it again a cosinusoidal signal with a frequency of Fc and an amplitude AC. So I can write the mathematical expression of carrier signal is AC cos 2 pi Fct. Okay. Now in order to draw the frequency spectrum of carrier signal, simply apply the Fourier transform to C of t. So if I apply the Fourier transform to C of t expression, then it will be C of f which is equal to Fourier transform of AC into cos 2 pi Fct. So we know what is the Fourier transform of AC cos 2 pi Fct. It is AC by 2 into del of f minus Fc plus del of f plus Fc. So this is the Fourier transform expression. So the frequency spectrum of carrier signal will consist of only an impulse signals. Why? Because the equation is having an impulse signal. So the same frequency spectrum will be drawn as in the case we consider in the message signal as an arbitrary signal. So it is F and it is C of F, and the first term is again an impulse signal with a shifting frequency of Fc which is having an amplitude of AC by 2, and the second term is having an impulse signal with a shifting frequency of minus Fc with an amplitude of AC by 2. So this is how to draw the frequency spectrum of carrier signal. Okay, let us see how to draw the frequency spectrum of an AM signal. So in order to draw the frequency spectrum of AM signal, we have to find out the AM signal equation in terms of frequency. So we know the time domain expression of AM signal. So the modulated time domain expression of AM signal S of t value will be C of t into 1 plus Ka M of t. Okay, in this case the M of t expression value is AM into cos 2 pi FMT and the value of Ka will be 1 by AC which is nothing but an amplitude sensitivity, and the C of t expression we are assuming it as a AC cos 2 pi Fct. Now simply substitute these values in S of t expression. So we will get finally its value is AC into cos 2 pi Fct into 1 plus 1 by AC into M of t value is AM cos 2 pi FMT. Okay, I can write the ratio of AM by AC is nothing but a modulation index. Okay, so from the definition of modulation index, M is equal to AM by AC, simply substitute. So finally its value will be AC into cos of 2 pi Fct into 1 plus M into cos 2 pi FMT, where M is a modulation index and its value is AM by AC. Okay, now if I multiply the expression, so finally it will get it is AC into cos 2 pi Fct plus M into AC into cos 2 pi FMT into cos 2 pi Fct. Okay, in this case here we are obtaining two cos signals, multiply. So cos A, cos B. From the trigonometry properties, simply substitute what is the value of cos A and cos B. So cos A, cos B is equal to 1 by 2 into cos of A plus B plus cos of A minus B. So from the trigonometry theory, if you substitute the values of cos 2 pi FMT into cos 2 pi FCT, we will get the value final expression as S of t is equal to AC cos 2 pi FCT plus m into AC by 2 into cos A cos B, right? So its value is cos of A plus B plus cos of A minus B. So it is cos of, what is the A value? So A value is 2 pi FMT and B value is 2 pi FCT. Now simply common 2 pi. So we will get it as cos of 2 pi into Fc plus Fm into T plus cos of 2 pi into A minus B. So here always assume the A is a high frequency component and B is a low frequency component. Why? Because we are having frequencies will be positive practically. So its value is 2 pi into Fc minus Fm into T. So the S of T expression, it is AC cos 2 pi FCT plus m into AC by 2 into cos 2 pi of Fc plus Fm into T plus m into AC by 2 into cos 2 pi of Fc minus Fm into T. So in the previous video, we said that the frequency expression of AM signal will consist of three frequencies. One is a carrier frequency and second one is an upper sideband frequency, which is called the highest frequency, and third one is a lower sideband frequency. So with the known message signal mathematical expression, so in the time domain equation itself, we are having three frequencies. So one is a carrier signal frequency, that is Fc. Okay, and second one is an upper sideband frequency with a value of Fc plus Fm, and the third one is a lower sideband frequency with a value of Fc minus Fm. Now let us see how to draw the frequency spectrum. So in order to draw the frequency spectrum, first what we have to do, we have to find out the Fourier transform of S of t. So if I apply the Fourier transform of f of t, then the final expression will consist of only cosinusoidal signals. Okay, so cosinusoidal signal, if I apply Fourier transform, then it will be one impulse signal with a shifting frequency of plus or minus Fc, and the second term is also an impulse signal with a shifting frequency of Fc plus Fm and minus of Fc plus Fm, and the third term is again an impulse signal with a shifting frequency of Fc minus Fm and minus of Fc minus Fm. Okay, so if I apply the Fourier transform of S of t, then it will be S of f, and so for the first term the Fourier transform is AC cos 2 pi FCT, and for the second term the Fourier transform, if you apply, then it is m into AC by 2 cos of 2 pi into Fc plus Fm into T, and the third term Fourier transform of m into AC by 2 into cos of 2 pi of Fc minus Fm into T. So if I write the Fourier transform, then the S of f value will be AC by 2 into del of f plus Fc plus del of f minus Fc. And the next term Fourier transform will be m into AC by 2 into del of f minus of, what is the frequency term? It is Fc plus Fm plus del of f minus of Fc plus Fm, sorry, f plus Fc plus Fm by 2. Okay, and the third term is m into AC by 2 into del of f minus Fc minus Fm in Fm plus del of f plus Fc minus Fm by 2. Okay, so if I simplify this equation, then it will be S of f is equal to AC by 2 into del of f minus Fc plus del of f plus Fc, and next term will be m into AC by 4 into del of f minus of Fc plus Fm plus del of f plus Fc plus Fm, and the third term will be m into AC by 4 into del of f minus of fc minus fm plus del of f minus plus of fc minus fm. Okay, so for this equation we have to draw the frequency spectrum. So if I draw the frequency spectrum of this AM signal, so its value is, sorry, S of f. Okay, now here the first term is again an impulse signal with a shifting frequency of fc and is having an amplitude AC by 2. Okay, so it is an fc frequency which is having an amplitude AC by 2. Similarly, at the negative side if I draw, then it will be minus fc with an amplitude AC by 2. Okay, so the first two terms are over, and the third term is again an impulse signal with a shifting frequency of fc plus fm, which means it is a higher frequency greater than the carrier signal frequency fc, and its amplitude is m into AC by 4. Okay, here the modulation index value will be AM by AC, so from that AC will cancel, so finally it is AM by 4 which is less than AC by 2. So here the third frequency component is fc plus fm with an amplitude m into AC by 4. Okay, and the fourth frequency term is fc plus fm with a negative frequency shift. So here I can write it as minus of fc plus fm. So minus of fc plus fm with an amplitude m into AC by 4. Okay, now the fifth frequency component is fc minus fm, which is a lower sideband frequency or lowest frequency compared to the carrier frequency, and its amplitude is m into AC by 4, which is same as an amplitude on a upper sideband frequency. So if I draw, then it is again an impulse signal which is having a frequency of fc minus fm with an amplitude m into AC by 4. Okay, and in the negative side, that is the last term, again its frequency is minus of fc minus fm, so and its amplitude is m into AC by 4. So finally this is how to draw the frequency spectrum for a single tone modulation by considering the message signal as a cosinusoidal signal. Thank you for watching our videos. Keep supporting.